Hi, today's lesson is on simplifying rational expressions. So this is largely just an algebraic lesson. You're just learning how to do something with algebra, and you won't be using it in word problems really until advanced functions. Now, a rational expression is something like this. It's an expression because there's no equal sign. It doesn't equal anything. And it's rational because it's an expression divided by another expression. So in other words, it's kind of like an expression fraction. Okay? So this is really ugly and big and gross. So we want to be able to simplify it. And that's basically what we're learning how to do today. So students often want to do things like, oh, well, we have an x squared on the top and an x squared on the bottom, so let's just cross them off. Well, you can't do that because they're still being added and subtracted. Just like if you had 1 plus 2 divided by 1 plus 3, you couldn't just cross that off to be 2 out of 3, because in reality it's 3 over 4, which isn't the same as 2 out of 3. So the only time when you can cross things off or simplify things by removing something from the top and the bottom is when everything is all multiplied together, and that means that it's a factor of the top and a factor of the bottom. So the word factor should give you a hint on how we're going to actually simplify these. We need to factor the top expression and factor the bottom expression, and then see what we can cross off. So when we factor this, you get x minus 5, x minus 3, divided by x minus 5, x minus 2. So notice that x minus 5 is multiplied on both the top and the bottom expression. So that can be crossed off, and you're left with just x minus 3 over x minus 2. Okay? Now there's a little more complication with what we're doing, but that's basically the gist of what we're doing in today's lesson, is taking something like this and simplifying it as much as we can. And again, this year we're just learning the algebraic, how to do that. Okay, whereas next year we'll actually be learning it and using it in problem solving and in graphing. So it's an important skill to learn. So I hope that you're all up on your factoring skills. Those are going to be essential in today's lesson. So if you're feeling a little bit uncomfortable with factoring, I recommend that you spend some more time practicing factoring and rewatching any factoring videos. Okay, so a rational number is a quotient, A over B, where A, B are integers. Okay, this weird Z stands for integers, which means they're not decimals. It just can be a negative or a positive whole number if you want to think about it that way. Up to 2 integers where the denominator cannot be 0. We can't divide by 0. A is called the numerator, and B the denominator. Okay, so examples would be like 2/3 minus 5/12. A non-example would be something like 2.5 over 3. Okay, that is not an integer, so that is not a rational number. Or something like root 3 over 5. Again, root 3 is not a rational number. So, root 3 is not an integer, so therefore this is not a rational number. So when you're looking just at numbers, we start with numbers because remember, expressions, polynomials, they're just like numbers. So whatever we can do with numbers, we can do with the expressions. Whatever we can't do with numbers, we can't do with expressions. So that's why I show you the numbers first, because they often make more sense to you than when you get all those x's and p's and q's and stuff in there. So you can reduce a rational number only if a number can be distributed through the entire numerator and the denominator. So for instance, 3 and 9, it could be, we all know that this is actually just 1/3. But why is it 1/3? Well, because if we have a 3 on the top, 9 can be written as 3 times 3. So these cross out. 3 divided by 3 is just 1. So you're left with 1/3. Now you might not have thought about it that way before, but thinking about it that way will help you in understanding the expressions. So 16 out of 42, well, what's common to both of them? They can both be divided by 2. So we can rewrite 16 as 2 times 8 and 42 as 2 times 21. The 2's cross out. 2 divided by 2 is 1. So you're just left with 8 divided by 21. Okay, so with something like this, you would need to actually do the addition first. So in this case, you would get 6 over 10. And again, since there's a 2 that can be factored out of both of those and then divided, you get 3 over 5. Now here, students are often tempted to just cross out these 3's and say, oh, we just have 2 over 5 left over. You can't do that, okay, because it's addition. Okay, 3 plus 2 is 5, and 3 plus 5 is 8. So notice if you had crossed out the 3's, you would have just been left with 2/5. Now if you put 2/5 and 5/8 in your calculator, you'll see you don't get the same decimal. So again, for addition, you can't cross out. It has to be multiplied like this before you can cross it out. Now in this case, 9 is multiplied by the entire top, and 6 is multiplied by the entire denominator. So you can actually factor 3 out of both of these. So this can become 3, and this can become 2. Now, you can do that even though you're saying, well, there's addition here, Mrs. Weens. How can we do that? Well, that's because this 9 and 6 is already factored out. It's already multiplied by the entire expression. So you can do that there. So then you would get 3 times 3 and 2 times 5. So you'd end up with 9 over 10. Okay. So I hope that makes sense to you, because now we're going to move on to expressions which have variables in them. So a rational expression is the quotient of two polynomial expressions. And again, the denominator cannot equal 0 because we can't divide by 0. It would explode. Don't want to do that. Okay, so a rational function is one where we say r at x is equal to p at x over q at x. But we say that the function q at x cannot equal 0. So for example, r at x could be 2x minus 1 divided by x plus 5. Now think about it. X plus 5 cannot equal 0 because that's the denominator. We can't divide by 0. So therefore, x cannot equal negative 5. So I just rearrange the formula. So x cannot equal negative 5. If I put that into this function, you get a denominator of 0. Boom, it explodes. We don't like that. Okay? So, rational expressions and functions are undefined for numbers that make the denominator 0. These numbers must be removed from the domain of the function. So, for example, you must find all values that make this denominator equal to 0. Okay? So we're trying to find the restrictions. The restrictions are the x values that make the denominator 0. So we need to find out what those are so we can restrict them from the domain. So to find the restrictions here, we must find all values of x that make x squared minus 2x minus 3 equal to 0. So we can't rearrange for x. So in order to do this, we have to first factor the denominator. Okay? So we leave 3x plus 1 as the numerator, and then we think two numbers that multiply to negative 3 and add to negative 2. So x minus 3 and x plus 1 fit that description. Then we set each factor equal to 0 and solve for x. So x minus 3 equals 0, so x equals 3, and x plus 1 equals 0, so x equals negative 1. So therefore, we write the restrictions and the domain. So x cannot equal 3, comma, negative 1. So our domain, I'm going to write it over here because I'm running out of spot here. So the domain of this function would be x such that x cannot equal, now I'm going to put negative 1 first just because it comes first, negative 1, comma, 3, and x is in the set of all real numbers. So this is saying that x can be any real number, it just can't be negative 1 or 3, because either one of those would make this denominator 0. So next year you'll learn that that creates a vertical asymptote in the graph of this function. But again, we're not really doing much with this year. You just have to learn algebraically how to do it and come up with the domain. So that's the simplest example. And the rest of the note today will just be going through more and more difficult examples of this. Okay, so rational expressions can only be simplified if there is a common factor in the numerator and the denominator. So, for example, this 3x squared over 2x. If you like to rewrite it like this, 3x squared is 3 times x, correct? And 2x is just 2 times x. So, because there's an x common on the top and the bottom, one of the x's can be canceled out, and you're left with 3x over 2. Okay? Now, this isn't complete until you add the restriction. You always have to include the restriction, and the restriction has to come from the original equation. So even though I don't have an x on the denominator of my simplified function, or expression, I had one in my original expression, so I need to include that x cannot equal 0. Okay? Again, you can also just think about your exponent laws. X squared divided by x, you just subtract the exponents. This has an imaginary little 1 on it. 2 minus 1 is 1, so you just have an x to the power 1. So similarly, 4a divided by 12a cubed. So first, I just think of the numbers. How can I simplify the numbers? Well, 4 over 12 simplifies to 1 over 3, so that's what's going on with the numbers. Now I deal with the variables. So I have an a down here and 3 a's on the denominator, so I'm just left with 2 a's on the denominator. Again, 1 minus 3 is negative 2, so there should be an a squared on the denominator. And we again have that a cannot equal 0. Okay, here, first, before we can reduce this by factoring out this x, by crossing out this x, we have to actually show that x is multiplied by everything on the top. So you factor out, common factor out an x, then you're left with 3x plus 1 over x. Okay? Now this shows that x is multiplied by everything on the top, so then you can cross it off with the denominator. So you cross those off, and you're left with just 3x plus 1. And you might be saying, oh, there's no restriction because I have no denominator. But remember, for restrictions, you have to look at the original. So we still have to include that x cannot equal 0. This one, I put here specifically, this cannot be reduced. Okay, you cannot cross off those x's because x is not multiplied by everything on the top. It's an addition sentence. So you can't do anything with that. Be very careful with expressions like this. It's a very common mistake for students to cross off those x's. So don't let it be you. With this one, you'll see it's already a factored expression on the top and a factored expression on the bottom. So since x plus 2 is multiplied by everything, it can be crossed off both the top and the bottom. So you're just left with x minus 1 all over x minus 3. Your restrictions now, you have to look at the original expression. So x cannot equal negative 2 or positive 3, because either one of those values would create a denominator of 0 in the original expression. Okay, so this we can't cross off anything right now because nothing's multiplied. It's all just added or subtracted. So what you have to do is factor the top and factor the bottom. So you guys go ahead and try to do that. I'll do it up here. But I hope that your factoring skills are strong because that is absolutely necessary in this unit. Okay, so you should have an x plus 5 on both the top and the bottom. And that can be divided out to be just 1. So you're left with just x minus 2 all over x plus 3. Okay, your restrictions are x cannot equal negative 5 or negative 3. Now, here we go with this b minus a over a minus b. this is what people get confused about. People often think that this is just equal to 1, but it's not, okay? A plus B over B plus A, which is equal to 1, because A plus B and B plus A are the same thing. But A, B minus A, and A minus B, those are not the same thing. So I'm going to erase this and we'll figure out what that is. Okay, we can start making some guesses as to what that will be when we reduce it. Okay, so in order for us to cross something off, we need to have the same expression on the top and the same expression on the bottom. So how can we turn B minus A into A minus B? Well, if you put a -1 outside, okay, you get negative B plus A. So I'm just going to leave the denominator the same. Okay, let me explain that. So if I factor out a -1, that just means I'm dividing both of the terms by -1.